Hello, andariki ela unnaru? Hi, am I audible? All of you? Hello, everyone. How's the energy, Sarji? How's the energy? So, students, in session we will be starting with vectors as a new chapter. Hello, Radhe Reddy. Hello, Spandana. Hi, Shalini. Hello. Yeah. So, how are you all? Where is the student council? 7 only watching. Hi, Naina. Hi. Hello, Soumya. So, shall we start the session, everyone? Good evening. Andariki, good evening. Kerala Chari, good evening. So, Sarji, in session lo, we are going to talk about vectors, right? You're talking to me, Spandana. Okay, I've taken your name, okay? Hi. Hey, it's not morning, Ray. It's evening, Ray. Yeah, good evening. All of you, good evening. Sorry, Cheppandi, how's the confidence level? We can start it. Start cheyala Mari. Arey, very good evening, Andariki, very good evening. Chalo, let's start the session, huh? ఎలా ఉన్నారు guys? ఎలా ఉన్నారు? Good to go, right? Good to go, Ray. Chalo. Like the video, everyone. Like the video. 20 people watching and only 7 likes, kada. So it's a very injustice, Ray. You know? Andariki like cheyandi video ni. And we start with the vectors. The next chapter, students, tomorrow also we will be having a class, okay? And Sunday special is electrostatics for the droppers. So droppers join cheyochu. The topic for tomorrow will be entire electrostatics, kada. So Sunday special is electrostatics, andariki. Chalo. Good. Kani, the number of students that have joined is not good, right? I'm not happy today, you know, because very less students have joined in today's class. Anyway, let's start the session. Vectors gurunchi maatladtam, sir. What is vectors, sir? Enduku maatladale vectors gurunchi ante? Every quantity, students, it can be classified into 3 categories. It is either a scalar quantity, లేదా vector quantity, లేదంటే tensor quantity. So sir, what are these terminologies and ఎందుకు డిస్కస్ చేయాలి అంటే చూడండి, for example, if I have only numbers అంటే my weight is 60 kgs, or for example the temperature today is 30 degrees, it is a simple number quantity kada. It's a single value that is giving you the estimation about whatever it is there. So for that, scalars is used. So scalars ante enti search ante it is only the numbers. It is a quantity that is explicitly expressed by using only values or numbers. So examples enti ante Sarji, temperature, Sarji example is weight, Sarji next example is time, Sarji, next example is money that you have. Money, money, money. Okay, sir, what are the vectors? Ante vectors are the quantities which are not explicitly described only by the numbers. Ante kada? So vectors need direction also. So vectors ante enti Sarji ante vectors need both magnitude ante. So what are tensors, Sarji? Tensor is a third quantity. Malli oka quantity that is resembles vectors and tensors also. Ante. Array definition only ra. You just understand it, okay? So ippudu chuddam. Let's say I have 3 kg of rice. 3 kg of rice andariki. Na degra 3 kg of rice is there. I'm adding 2 kg of rice into it. So 3 kg plus 2 kg is definitely 5 kg. Sir, no problem at all. It is going well and good. Okay, sir ji. Na degra 10 liters of oil is there and 20 liter of oil kuda undi. I'm adding the 2 oils. So 10 liters plus 20 liters is equals to 30 liters. Ante kada, no problem at all. Everything going very smooth and fine. Kani, when you talk about the forces, what is the value of 10 plus 10 Newton? Force Sarji, the value of 10 plus 10 should be 20 kada. Ideally, if you are thinking, sir, the value of 10 plus 10 should equals to be 20. Okay, sir, 10 plus 10 is equals to 20. Ardhamaindi. Kani, I'll tell you a scenario, ra. Let's imagine na degra oka block untundi, and let's say the mass of this block is 10 kgs or edaina re, does not matter. Let's say the mass of the block is m. A scenario lo, let's say here is a person, here is another person, Sarji. This is applying 10 Newton force in the right side. Vaadu kuda is applying 10 Newton force in the left side. Cheppandi, what is net force ra? What is net force ra? What is net force? Cheppandi, what is the net force in this scenario? So sir ji, net force is equals to 0, sir. Endukante opposite directions kada. Same situation we will take it, kani I am only changing the directions ra. Chudandi andariki. Let's say this is the same block, this is the same person, and this is the same other person. 10 Newton force applied by this, 10 Newton force applied by this. Yenta, how much 10 plus 10? Good. So 10 plus 10 in this scenario is 20 Newton. So Sarji, 10 plus 10 is 0. Here also 10 plus 10 is 20, sir. Why, Sarji? Why is it happening? Because of the direction, kada? Good. So if the direction is changed, the value also changes. Ante kada? So this value is solely coming because of the directions. Good. Endukante there is a single reason, and that reason is about the direction. Okay, sir. So that means I have a block of mass m, for example, I'm telling. And sir, I'm applying a force of 10 Newton on this block in this direction. So idi na 10 Newton ki force. Good, sir. But. Instead of applying the second force horizontally, I'm changing something, right? I'm changing the assembly. Let's say the other force, 10 Newton, e direction lo act chestunnaru. Ippudu cheppandi, what is the net force, ra? 10 plus 10 is what in this scenario? So chudandi. This was my 10. This was my 10. Same direction, kada? Same direction. So same directions lo unte 10 plus 10 is 20. Good, sir. Understood. Okay, sir, if this is my 10 and if this is my 10, opposite directions kada. So 10 plus 10 enta ante it comes out to be 0. Sir, we understood the two scenarios. Kani, what would happen if this is 10 and this is 10? Cheppandi, what is 10 plus 10? Oh, sir, it is a very twist now. And I don't know the answer for this kada. So for this, we study the vectors. Ante kada? Not 0, Raju, not 0. In this scenario, it will not be 0. Chalo, so we have to study the same thing. So sir, why did it happen? Why 10 plus 10 is 20 and why 10 plus 10 is 0? So students, can I ask, is it possible 10 plus 10 is equals to 15 also? 10 plus 10, 15 is possible or impossible? Cheppandi andariki. Very possible, sir. Very possible. Depend upon the situation. Ela forces exert chestunnaru on that situation is completely dependent if 10 plus 10 is 15 or not. Similarly, if I'm asking, sir, 10 plus 20 is equals to 10. Possible, impossible? Possible, impossible? Possible, sir. Very good possible. Elante student, this is the block, this is the 10 kg, this is the 20 kg mass. Sorry, 10 Newton and it is 20 Newton. Cheppandi 10, 20. 10, 20. Net force ఏంటిరా? Subtract చేసుకోండి. Net force is 10 Newton only. ఎందుకంటే opposite forces కదా. So sir, 10 plus 10 is 5 also. 10 plus 10 is 10 also. 10 plus 10 is 20 also. Why happening, sir? Why is it happening ante? Only and only due to the directions kada. The only reason why 10 plus 10 is, I don't know what is the value of 10 plus 10, right? ఎందుకంటే I don't know the directions. Directions is there, I can definitely calculate what is 10 plus 10 or what is 10 plus 20. Ante kada? Good. So the quantities whose addition or subtraction is dependent on the direction are known as vectors. Okay, sir. Now it has clicked me. So if at all I want 10 plus 10, I want to know the direction also. So aim direction lo our forces act chestunnaru. Ante sir, I understood till this point. So students, now that we done talking about the vectors, ippudu naming of the vectors gurinchi maatladtam. So how to name the vector? How to name the vector? How to name the vector? Cheppandi andariki. How can I name the vector? Naming of a vector can be done in various ways. For example, sir, a vector name should be a letter. Okay, sir, it is A. Or sir, a letter can also be like this. Okay, sir, ardhamaindi. Kani. Sir, it is incomplete, sir. This name is incomplete. Endukante it is only talking about the value kada. A is only the value. ఇప్పుడు what about direction, sir? Oh, the direction is also remaining ra. So direction గురించి ఏం రావాలంటే చూసుకోండి. Direction అంటే sir, we just write an arrow. Okay, so that means A is only for value and E bar on the head ante it is for the direction. Sir, I have a doubt. Is it okay if I write the name in this way? Or sir, is it okay if I write the name in that way? Okay, no problem at all. Ela kuda rayochu. So you can write the name of the vectors in 1, 2, 3, 4 different ways. Ante kada? No. Sir, there is one more way we can write it. What way? What is the way? So sir, you write bold letters, sir. Bold letters ante this is my normal letter. Naku bold letters kavala. So what to write for bold letters? Bold letters, something like this. So this is also a complete name for vector A. Or leda, this is also a complete name of a vector. Ante kada? So you can write bold letters or you can write the bars on the head. Can you observe cheskondi? Epadaina I am telling you, whenever I am telling you, I have this sort of vector. So if I only have the letter, not the bar on the head, only vector ante it is only for the value. So sir, 10 Newton is the force and the 10 Newton. But ekkada 10 Newton, where is it acting? Right, left, up, down, ekkada act chestunnaru. For that direction we need a bar. So it is complete representation kada. Complete representation. Are complete representation of what, re? Complete representation of value plus direction. Okay, sir, I understood. So I can name the vectors in all these ways. Kani, if I am only interested about the value, I will not write the bar on the head. Ardhamaindi kada? Andariki cheppandi nagu. Ardhamaindi kada? What is the chat going on? Re. Cheppandi. How are you guys? How are you andariki? Nandini, I'm good. Chalo. Good. ఎప్పుడు చూసుకోండి. Now, let's move ahead. How to represent a vector? So for representing a vector, we need both the things kada. నాకు value కూడా కావాలి, నాకు direction కూడా కావాలి. So ఈ figure లో you only have directions kada, not about the values. So values కూడా ఏం రావాలంటే, you simply say the value of this vector a bar is 10. అర్థమైంది కదా? It could be force, it could be acceleration, it could be displacement, it could be velocity. ఏదైనా you can take as you want. So sir, a bar అంటే I have both the things. ఎప్పుడు చెప్పినా కదా నేను, if at all you have a vector a bar. So ఈ representation లో this bar or this line represents the direction. Again I'm telling you, జాగ్రత్తగా గుర్తు పెట్టుకోండి. రే చూసుకోండి ఇక్కడ. So what I'm telling to you is this a bar head is only for the direction. So ఇక్కడ right side kada. So if I talk about the b bar is for the representation, left side kada. If I say c bar is for the direction. See this direction kada. And here if I say d bar, it is only for the direction. Bar. ఎప్పుడు సర్జీ బి బార్ ఇస్ ఆల్సో ఇన్కంప్లీట్. ఎందుకంటే ఓన్లీ డైరెక్షన్ ఇస్ దేర్ రే, నాట్ అబౌట్ ద వాల్యూ ఆఫ్ దట్ వెక్టర్. సో ఏం చేయాలి సర్జీ? గివ్ మీ ద వాల్యూ. ఫర్ ఎగ్జాంపుల్ లెట్స్ సే 20 meters కి డిస్ప్లేస్మెంట్. ఎప్పుడు ద వెక్టర్ ఇస్ సక్సెస్ఫుల్లీ రిటర్న్. అర్థమైంది కదా? గుడ్. హియర్ ఆల్సో ద రిప్రజెంటేషన్ ఇస్ ఇన్కంప్లీట్ సర్జీ, ఎందుకంటే ఓన్లీ డైరెక్షన్ ఇస్ దేర్. బట్ ద నేమ్ ఇస్ కంప్లీట్. చూసుకోండి, నేమ్ హ్యాస్ బోత్ లెటర్ అండ్ బార్ ఆల్సో. So in that scenario, name is complete, kani representation ante incomplete. What is missing? Value is missing kada. So tell me. So sir ji, value is, let's say 2 meter per second is the velocity. So here 10 Newton example is of force. Ekkada vachi it is for the displacement. Cheppandi, in this scenario it is velocity kada. Good. So here it is velocity, and in this scenario let's take acceleration. Okay, so let's say value of the acceleration is 10 meter per second squared sirji. So in this scenario lo it is acceleration. Ante kada. So now onwards, remember, whenever a force is given to you, the representation will be along the arrow. So sir ji, ee phone ki I'm holding it, I'm pulling it in the upward direction kada. So ekkada force apply chestunnaru? In the upward direction sir ji. So the direction of this force is in upward direction. Kani value enta? What is the value re? Okay sir, value is 5 Newton. Example sir, the value is 5 Newton. So now that I know the direction, how did I know it? Because I've seen it kada. I'm lifting the phone in the upward direction. So upward lift cheste, the force is in the upward direction. So I'm pushing something in the right side, and the direction is in the right side kada. Ardham vastundaru? Good. So here I can say, let's say the value of force is equals to, sir, simply 20 Newton, and the direction is in the right side. So now I have to explicitly mention it in a naming the representation. Cheppandi. So let's say na దగ్గర a bar is the vector. Kani, what is the value? What is the value? 20 Newton. So for value, we don't write this bar kada. We don't want this bar for value. So I'll simply say a is equals to 20. So a statement nunchi, what are you coming to know? We are only coming to know about the value, not the direction. For direction, you must see the arrow. Ardhamindi kada? Good. So now, Sarji, I only know about the value. So value ante the magnitude of the vector kada? Okay, sir. So can I simply say that the magnitude of the vector ante only the value of the vector? Ante kada? So, Sarji, how to find the value ante? You do one thing, you take the original vector, a vector nunchi you take out the direction kada? Ante. So, it is nothing but the original vector minus the direction. Ardhamaindi andariki. So 10 Newton in the right, 10 Newton in the right, remove the direction, 10 Newton, 10 Newton, 10 Newton is the magnitude of this vector. Ardhamaindi andariki. Now, all of you, we can also write the magnitude of the vector via these two lines. So, idi ante magnitude kada. So, if I say magnitude of A bar, what does these two lines do? What do these two lines do? It will only remove the direction. Ante. So, this and this, these two lines and this line, these two lines and this line gets cancelled. And I'll only left with A, and the value of A is 10 Newton kada, 20 Newton, whatever value it is. 20 Newton, 20 Newton. Ante. Next. Next, Baba, magnitude versus vector. Magnitude versus vector. So, Chappandi, if I say A bar is equals to 15 Newton, Chappandi, what is the magnitude of vector? Andariki, all of you. Andariki, Chappandi. What is the value of the magnitude of the vector? Magnitude of the vector is mod A bar, mod or magnitude, same. You can say mod A bar is equals to simply A is equals to 15. Okay, sir. Now, let's say the value of the name of this vector is B bar and 20 meter per second square. It is the acceleration in the upward direction. I have thrown this pen upward ray. Where is the acceleration? Downwards kada. And where is the speed ray? Speed is in the upward direction. Acceleration upward, you can take you want, or you can take the speed also. So here I am considering the speed 20 meter per second in the upward direction, right? When I throw this pen in the upward direction. So Chappandi, magnitude of the vector entara elara vale, magnitude of the vector is simply mod B bar. Sarji, mod B bar ante, can you simply write is equals to B? Yes, you can. Chappandi, what is the value rate? 20 ante meter per second. So you can never know the direction only by looking at the magnitude kada. Hey Nandini, spelling. Hey, what are you typing, Nandini? How are you typing, Nandini? Chalo. Next. Okay, sir. Magnitude ante only value, Sarji. Magnitude doesn't give direction. Magnitude doesn't give direction. Ante kada? Good. Now, let's talk something about angle between the vectors. Andariki. What I want you to observe here is angle between the vectors. So, angle Gurunji Cheppadaniki, you will have to, have a detailed idea about the angle between the vectors. Sarji, what is angle? Angle ante whenever two lines are intersecting, or whenever the two lines are meeting, the space between them. You know the value of angle. Don't let me tell you like class 1 students. Andariki. So it is the angle kada, theta. It is the angle. It is the angle. It is the angle. Chalo. So now, angle is theta, sir. So if I say here also theta, and if I say here also theta, can I say this theta is the angle between the vectors? Yes or no? Can I say this theta is the angle between the vectors? Okay, Nandini, no problem. Okay. Cheppandi andariki. Is theta the angle between the vectors? Yes or no? No. No. Arre, no re baba. No, it is not the angle between the vectors. ఎక్కడ కూడా it is not the angle between the vectors. ఎందుకు సర్జీ అంటే angle is only defined in the two different scenarios. The first scenario is, okay, I'll tell you about more about the representation of vectors. ఎక్కడ చూడండి అందరికి. So if I write the arrow, చూసుకోండి, this side is known as the head of the vector కదా, and this side is known as the tail of vectors. అందరికి అర్థమైంది చెప్పండి. ఎక్కడ కూడా if I'm talking about the head and tail, I'll say this is the head and this is the tail of the vector. అర్థమైంది. Now students చూసుకోండి, there is a rule for calculating or finding the angle between the vectors. ఏం రూల్ అంటే సర్జీ, for finding or for telling that this is angle between the vectors. Very good Isha, very good. The angle is only considered when the two vectors are joined either head to head or tail to tail. చూసుకోండి, this is the first vector, ఇది నా second vector, or this is the first vector and this is my second vector. Joining చూసుకోండి, this is tail to tail కదా, overlap. So this is tail overlap. ఎక్కడ వచ్చి this is head overlap. You remember this is not the angle between the vectors ray. If you apply the same formula in resultant of vectors, your answer will be gone. అంతే కదా, good. So angle between the vectors is only valid when you have head to head or tail to tail combination. Ante kada, good. So a scenario lo, let's say 60 degrees there and ekkada let's say 45 degrees there. So here I can say theta is 60 degrees and theta is 45 degrees. Okay sir, so if so Sarji, if this is 60 and if this is 120, so here theta is not equals to 60. Theta ante, always remember, theta is always the angle between the vectors. So I am writing here, చూసుకోండి, you can put it in your mind or notebooks, whatever you want. Theta is always the angle between the vectors. ఎందుకంటే we are discussing about dot product AB cos theta, cross product AB sin theta, resultant under root A square plus B square plus 2AB cos theta. మొత్తం ఫార్ములాస్ లో theta అంటే always the angle between the vectors. Here theta is not 60. అర్థమైంది? Always the angle between the vectors. Okay sir, always the angle between the vectors. అర్థమైంది, good. So sir, ఏం చేయాలా in this scenario sirji? Here it is not making the angle between the vectors kada, good. Okay, good. So here okay, చెప్పండి find the angle between the vectors అంటారు. So let's say this is 45 degrees. Question number 1. Question number 2, say this is 60 degrees. Question number 3, quick అందరికి quick, తొందరగా చెప్పండి, we don't have much time కదా. So this is 2, this is 3, this is 4, and this is 5, this is 5, this is 6. I'm not taking much examples kada. So let's say this is 1 and this is 2, ఇది 150 degrees. This is 1 and this is 2, this is 30 degrees kada. And let's talk about this scenario, 90 degrees, and also ekkada kuda this is 90 degrees. Cheppandi andariki, theta ki value enti ra? Is it theta is equals to 45? Yes or no? Theta is equals to 45. Yes or no? Yes or no? Andariki cheppandi, theta is 45. Yes or no? Thank you so much Nandini, thank you so much. Chalo cheppandi, here theta is equals to 60 degrees kada. It is no, not there. Endukante head to head matching is not there, tail to tail is also not there ra. Good. This is 60 degree kada. Here also theta is there, tail to tail combination. So I can write theta is equals to 150 in this scenario. It is not theta kada, ఎందుకంటే head to tail combinations, not theta re, not theta. ఎక్కడ వచ్చేసి it is tail to tail, so I can simply say sir theta is 90 degree. Here I cannot say kada. So what are not theta, sir? This one is not theta. Sir, this one is also not theta, and sir this is also not theta. అర్థమైంది? I'm only talking about theta, and whenever I say theta, you remember it is always I'm talking about the angle between the vectors. Very good, very good, very good. Next. So Sarji, what if the angle between the vectors is not there? So Sarji, let's say this is my scenario. So in scenario lo Sarji, I want to find the value of theta. Array, not theta re, it is 60 degrees re. So Sarji, what is the value of theta? What is theta? What is theta re? It is not 60. Theta is not 60 in this scenario ra. What is theta? What is theta re? So to find such angles, sir, we need one more property. Aim property and vector shifting property. Sir, what is this property, sir? What does this say? So this property simply says, మీ దగ్గర ఒక vector ఉంటే, this is the head of the vector kada, and this is the tail of the vector. చూసుకోండి అందరికి. If at all you have a vector in a plane, array, I understood, right? Okay, let me just try to draw something. Array, not like this, right? Not like this, right? Okay, so if at all I have a vector array, okay, so it is my vector kada. So what can I do? I can simply lift this vector anyways. Ekkada kuda I can simply shift it. Kani the only condition is that its magnitude should not be changed while shifting. First condition. What is the first condition, ra? The length should not increase. Length ante magnitude. Length ante magnitude. I'm telling you one more time. Remember, length ante magnitude. Length ante value. Length ante magnitude. Okay. So can I say that, Sarji, if at all I have a vector, I can lift it and I can shift it. Okay. So I can lift it and I can shift it anywhere in the plane kada. Something like this. I can shift it anywhere in any direction. The only two conditions are there. You should not. Cheppandi ra, cheppandi. You should not. Number one, change. You should not change. What you should not change, right? Number one, the value of the vector. And number two, the direction of the vector. Ante. As long as you are keeping the two things constant, ante value also constant, direction also constant. In that scenario, you can lift it, you can shift it anywhere you want. You are not changing the value, not increasing, not decreasing. Also, you are not changing the direction. Direction is also not changing. It's not your understanding. Good. Good. Magnitude and direction should always remain the same. Magnitude until length, I am telling you, magnitude until length. Observe cheskondi. If I shift the vector something like this, it is here and I am shifting downwards. Is it valid or invalid? Right? This shift is valid or invalid? Invalid. Endukante sir, I have changed the length kada. Endukante length is changed ra. Are length re. You just see re, length is changed re. You cannot change the length. Length ante magnitude kada. Good. Similarly, you cannot change the magnitude ra, direction ra. So you lift it and you do something like this and you shift it. No, you cannot do. In the direction is changed. Ade. So once you are done with that, so let's talk about the conversion of angle. So let's take one more scenario. In this scenario, this is my original vector A bar. Let's say this is my original vector B bar. And let's say this angle is 60 degree. What to do now? What to do? Cheppandi andariki. Cheppandi. I can simply say it is not the angle between the vectors kada. Endukante the head to head or tail to tail is not there. So I'll simply choose this vector and I'll shift it something like this. Idi kuda. And this also. Ardhamaindi andariki. Cheppandi. So this was my original vector. Chooskondi. This was my original vectors kada. So this angle is 60. How much angle this is? What is the angle here? All of you. Cheppandi, what is the angle? Can I say the angle in this scenario is 120? Can I say 120 andariki? Yes. Endukante straight line ray. Total angle is 180 kada, straight line. So you can say 120 degrees. Good. So Sarji, in this scenario, even if 60 degree appears to be the angle, it is not. Ardhamaindi. So here theta ki value enti ante 120 degrees. Ante kada. Cheppandi. What is the value of angle theta in this scenario? All of you tell me. Chalo. So this is first and this is second. This is 80 degrees. Cheppandi, what is the value of theta? All of you. What is the value of theta? What is the value of theta? Cheppandi ra. I need the answers, okay? Good to go, Good to go. Let's see now what happens. Not 160. Not 160, not 160. Not 0, Nandini, it's not 0. Angle between that angle here, vectors, Sarji. 60, not 60, not 60, not 60. Here theta is 120, ra. If you see it is 80 degrees, but 80 is not head to head, tail to tail ray. 80 is not head to head, tail to tail ray. 80 is not head to head, tail to tail. So, em cheyala, Sarji. You shift it, ray. What to shift, ray? You shift any of the vectors. You shift. So here I am shifting this one. Choose kondi. Here I am shifting this. This. Ade. So this arrow also. How should I do, ray? How should I do? So you just observe, it is going into the another question. Can you just wrap? You just observe, okay? So this is the head. So I shifted it this way. Now this is the angle between the vectors. Good, very good. Darken, very good darken. It's 100 degrees. This was the original angle given to me as 80 degrees. And it is a total straight line, kada. So you just observe it is 180 total minus 80. So it is 100 degrees, 100 degrees. 100 degrees, kada? What are you typing in the comments, Ray? Bhanu, it's not 150. How can you say it's 150, Ray? I think we will have to take few more questions then in this scenario. Choose kondi. The question is find the angle between the vectors. Alright, where is it going, Ray? Okay, so first one, right? First scenario. So this is now first question. Cheppandi, this angle is 50 degrees. What is the angle, right? 50 kada? What is the angle between the vectors in this scenario? Cheppandi andariki, what is the angle? What is the angle? It is not 50, Ray. 50 is only written to you, to confuse you. It is not 50. It is not head to head or tail to tail. Choose kondi. It is not head to head or tail to tail. What to do now? Shift. Which one to shift, sir? You shift any, whichever you want. Very good, Raju, very good. So I am shifting this one, right? I am shifting this one. Choose kondi. I am shifting it exactly in the straight direction. Here, and you lift it, you bring it here, kada. Okay, sir, I shifted. What was the original angle, sir? The original angle was this. How much was the original angle, sir? 50. Total is 180, kada. So you take out this 50 minus 180. So 180 minus 50, and it is 130 degrees. For the students who are lazy to do this work, very good, Harita, very good. Andariki, very good. So for the students who are lazy to do the work, you just observe this. If at all you have head to tail or head to head in the scenario 60, theta is 60, no problem at all, very good. If the combination is not head to head or tail to tail. Let's say 60 degrees there. You simply subtract this angle from 180. Simply subtract. Simply subtract from 180. Cheppandi 180 minus 60. How much? It is 120. You do simply shortcut. Ante. This is the angle between the vectors. Very good. Next. Whatever we have learned, we have to apply it. We have to apply whatever we have learned and we have to derive something. So the concept is known as addition of two vectors. So Sarji, what is 10 plus 10 and you are telling it is 20 kada? But you cannot say it's 20 in vectors. Endukante direction matters, direction matters kada. So for that we have to study two different laws. The first law is the triangle law. The second law is parallelogram law of vectors. So we will talk about the parallelogram law of vector addition. So what does it say, Sarji? The first thing, observe cheskondi. You need theta. Theta. What is theta? Theta is the angle between the vectors. So to calculate theta, you shift. If it is shifting there, you shift. If it is not there, directly given, you directly write it. Okay, sir. Let's imagine this is my first vector. This vector ki value until let's say 10. Good, Sarji. Let's go. Alright. Let's go to the next vector, sir. This vector ki value until let's say, Sarji, it is 20. And let's say this angle is 60 degrees. My first question to you is 60 degree angle between the vectors. Yes or no, Cheppandi? 60 degree angle between the vectors, it is there or not there? It is. Endukante sir, tail to tail combination kada. Now, very calmly you sit and very calmly you name the vector as vector A. And very calmly you name this vector as vector B. Ade. So, Sarji, I have to add the vector, but I don't know like how to do the addition. Ardhamandi. So, how to do the addition ante? We do have a formula, sir, that gives me the direct value of addition. Okay, sir, what is 10 plus 10 in this scenario? Sir, if this is 10 plus 20 kada, it is not 30, it is not 30. Not 30. And the directions are not same. Directions is different. So, Sarji, in this scenario, I have a formula. The formula says resultant vector is equals to square root of first vector v1 square plus square root of second vector v2 square plus 2 into v1 into v2 into cos theta. Sir, enti cos theta ante theta should be the angle between the vectors. Always remember, if it is not there, convert it, shift the vectors and then you write the value of theta. Good. So, Sarji, what is v1 ante? You can simply say v1 is this. And what is v2 ante? Whichever you want, you can take it. So I am calling this to be V1 and this to be V2. Cheppandi. So net value or resultant value is equals to root of V1 square ante 10 square kada. 10 square directly rastunaru 100. Ekkada cheppandi V2 square ante how much? 20 square ante 400. Good, Sarji. Plus 2 into V1 ante 10 kada. V1 is 10. V2 ante 20 kada. Good. So V2 is 20 into cos theta. Theta ki value entara 60. So cos 60 is 1 by 2. So this 2 and this 1 by 2 gets cancelled. Endukante they are in multiplication. Andariki chuskondi. So you can simply say it is root of 100 plus 400 plus 200 kada. So 400 plus 200 plus 100 ante 700. Ante. So it is root of 700. So if you want, you can take out 100 outside of the root. So you can simply say resultant vector is 10 root 7. So Sarji, for this sort of assembly, where my vectors are at 60 degree, the first is 10, the second is 20. So in this scenario, 10 plus 20 is not 30 ra. What is 10 plus 20 in this scenario? You can simply say 10 plus 20 is 10 root 7. Ante kada? Good. All of you, cheppandi, andariki cheppandi. So this 10 plus 20 is not 30 in this scenario. 10 plus 20 is 10 root 7 because we have calculated using the formula. Very good. Very good. Darken, very good. Good. Chalo. Next. I'm giving you the question. Tell me the final value. Okay. Final value. Cheppandi andariki. Let's say this angle is again 60 degrees. 20. Cheppandi andariki. 20. 60 degrees is the angle between the vectors. So you missed it, Spandana. I've told what to say. Kani. Arey, this is the question, right? Chuskondi andariki. What is the resultant? What is the resultant? What is the resultant? Cheppandi andariki. Arey, formula re sir ji. Formula. What is the formula, sir? Resultant vector is root of v1 squared plus v2 squared plus 2v1 v2 into cos theta. So, sir ji, the first thing that I have to calculate, not 2 root 2. Not 2 root 2. No, Ria, it's not 2 root 2. Not 20, Ria. Not 20, not 2, not 2 root 2. Chuskondi. So theta is 60 degrees kada, cos 60. You remember the values. For trigonometric values, it is must to have the idea of the trigonometric values. So resultant vectors VR is equals to root of V1 squared ante 20 squared, that is 400. Okay, sir. V2 squared ante this 20 squared, that is also 400. Okay, sir. No problem. Next, plus 2 times of Cheppandi V1 value ante 20. V2 is also 20. Cos theta ante cos 60 kada. Cos 60 is 1 by 2. So this 2 gets cancelled. So you can simply say root of 400 plus 20 into 20 again 400 kada. So 1200. So it is 1200. Okay, sir, you can multiply it 1200 as 400 into 3 kada. Good. So square root of 400 into 20, and that is into 2. So this is my resultant vector. Ardhamaindi andariki. Not root 400, sir ji. It's not root 400. It is root of 1200, sir ji. It is not root 400. Very good, Ria. Root of 1200. Very good. 1200. Good. Very good. Isha, very good. Okay, Darkan, very good. Nice. Now, I have to discuss a few more things to you, students. What did we say, Re? We say this 20 is a vector kada. When the direction is there, value is there. Sir, this 20 is also vector kada. Yes, sir, it is also vector. Direction is there, magnitude is there. So, sir, when we are adding the two vectors, what we get? We get a scalar or we get vector? When we are adding the two vectors, what we get, sir ji? Scalar or vector? So, sir, when we are adding the two vectors, we get the vector again. So, this is the vector kada. Kani, this vector is incomplete. Ardhamaindi, spirit. What is the spirit? What are you confused about, spirit? This is only the value, sir. It is not having directions. It is the only value, sir. 20 root 3, it's only value, not the direction. So, aim cheyala, sir, direction calculate cheyadaniki. You remember one thing for now. For this session, you remember one thing. Whenever you are calculating the resultant, I am telling you, for this session, you remember one thing. Whenever you are calculating the resultant, it will always be between the two vectors. Ardhamaindi andariki. So, sir ji, resultant gurunchi matladalante, the resultant of these two vectors will be always between the two vectors. Okay, sir, my resultant will be something like this. Ante kada, this is my resultant. Ee resultant ki value enti, sir ji? 20 root 3. Ade. Ardhamaindi andariki. Good. So, sir, whenever we are talking about the resultant of vectors, we are applying this formula. So, ela ochindi sir ji formula ante, it has a proof, but due to the time constraints, I am skipping it. No, it's not required for you also. Okay, if you remember the formula, sufficient. Okay. Anyhow, sir, if we know the proof, we are anyhow going to forget it. So assume I told you and you forget it. Next. Alright, not triangle law of vector addition, right? Let's take one more example on this. Okay. So let's say now this is my first vector. Let's say the value is 10 and this is my second vector, Sergi. Now let's see how many of you can tell me the right answer. E angle ante 60 degrees, e value kuda 10. Cheppandi. All of you, tell me. Cheppandi andariki. Hi, Chinnu Yadav. Spandana, what do you want? Like, what do you want me to explain once again? Root 300 kada? Good. Good. 10 root 3, good. Darken and Ria, good. So for your kind information, Darken and Ria, it is a well try, but the answer is not 10 root 3, okay? You have missed one thing, Ray. One thing. What is something that you missed, Ray? 60 is not between the angle of vectors, Ray. So you cannot take cos 60, Ray. You cannot take cos 60. Root 300 is wrong, andariki. Choose kondi. Root 300 is not the answer. Endukante this 60 is not the angle between the vectors. Adhamani kada? The 60 it is not the angle between the vectors. Yes. Good. So 60 is not the angle between the vectors. So you take one information, cos of 120 degree is minus 1 by 2. Okay, remember this because this will be something that will be required. Good. 120 degree is the angle. Very good. Ria, very good. Raju, very good. 120 is the angle between the vectors. So a scenario, you take 120 as theta, not 60 degrees. That's what I was telling to you from the beginning of the lecture, Ray. So I tried to, keep you away from this mud or this, valley, but ultimately you fell all over there itself again. Good. Cheppandi. So theta is 120 degrees, right? It's not 60 degrees. Again, I'm telling you, you remember, the angle is not 60 degrees, Sergi. So what we do is we simply take it and we simply shift it like this. Okay, I simply take it out. Ekkada shift chestunnaru. This or this also I'm shifting it here. Okay. So sir, this was my origin. So sir, this was my original scenario. This angle was 60 kada. Kani, this is the angle between the vectors 120. Ante. Ardhamaindi andariki. Okay, sir. So this value is also 10. So V net or resultant vector is root of V1 squared plus V2 squared plus 2V1 V2 into cos theta. Okay, ardhamaindi Sergi. Substitute cheskondi. V1 square ante 10 square ante 100. V2 square is also 100. Plus 2 into V1 is 10, V2 is also 10, cos theta ante cos 120. Cos 120, how much, Sergi? Minus 1 by 2. Substitute cheskondi, it is minus 1 by 2. Now students, I want you to observe only this part. E part ki observe cheskondi. This is plus kada, when this is minus kada. What is plus into minus, re? What is plus into minus, re? Bomu, J is a different, J has a different channel, it is for only NEETs. So, capacitor is there, we'll start it, but not now. So, this Sunday will completely be gone for, electrostatics, and dan tarvata we can start capacitors. Good. 10 is the answer. Very good. Very good, Darkin. Very good. Good, Raju. Very good. Okay. So this is negative kada, so it is root of, and this 2 also gets cancelled, right? So this is 10 square is 100 plus 10 square is 100 plus minus is minus, and this is 10 into 10 is also 100. So 100 minus 100 gets cancelled, only 100 and 10. Ardhamaindi? So Sarji, again I'm asking you the same thing. Sir. First vector is here. Second vector, initially second vector was given here. Kani it is not here kada, it is slightly downwards. So Kasari, you are finding the angle between the vectors. That is the original position of the vectors. Choose kondi. This is not the original vector now. Original vector is this. And the angle between the vectors is only forming here. So now you can say this is a vector. Sarji, this is also a vector. Alright. Sarji, this is also a vector. What did I say? Vector plus vector is also a vector. Choose kondi. Vector plus vector is also a vector. So Sarji, E value kuda vector kada. So if this is a vector, it should be having directions also. So direction ante sir, the direction of the vector is always in between the original vectors kada. So what are the original vectors there? These two. So the direction will be is between the original vectors, something like this. Ardham cheskondi andariki. You trust me, I am telling you, if you are assuming this to be the original vector and you are talking about the direction here, it is wrong, it is wrong. Original vectors are here. This is the first vector. This is the second vector. Ra. Yeah. Boom. Good. So you can say this is the original resultant direction. Good. Chalo. So let's take one more question and then we'll move towards the next part. Can draw it with my fingers only, right? It gives me the feel, okay? Not like this. So I should take something like this here. Okay, sir. E value until let's say 20, and let's say this value is 10, and this angle is 60 degrees. Cheppandi andariki. The resultant value. Quick, direction also, value also. I want both. Mottam kavalara, direction also, value also. Value and direction. Value and direction. Value and direction. What is the value, Ray? Sirji, these are not the original vectors. Sirji, these are not the original vectors. Indukante angle is not forming kada. So what you do, sir? I will simply shift this vector. Ela shift chestaru Sirji ante. This is the shifted vector kada. This also. Alright. And this also, Ray. Let's take very carefully from this part. Okay, sir. So this 10 is also shifted here. It was the value kada. Good. So this value is 10. And sir, my original vector or my initial vector was something like this. What is this angle, sir? It is 120 kada. Now remember, it is not the original vector. Original vector ante this one. So what did I say? This is a vector. This is a vector. Resultant will be the vector. Kani, the vector resultant will be in between the two vectors kada. So beta, in between what? Are in between what? Re? In between these two? In between these two? No. In between these two. So the resultant direction will be something here. Ardhamaindi andariki. Good. Let's see the value now. Choose kondi. So V resultant is equals to root of V1 square ante 100 plus V2 square ante 400 minus 2 into V1 is 10, V2 is 20 into cos 120 is minus half. I have taken already minus. I have taken already minus. Gone. 200. 400 plus 100 ante 500. 500 minus this 200 kada. So 500 minus 200 is root of 300. Cos of 120 is not minus half, it is minus half. Cos of 120 is minus half, not plus half, okay? So root 300 is answer, andariki. Very good. Very good, Haritha, very good. Chalo, I hope you understood till this point kada. Now I think we can go towards the next topics. Chuskondi. Triangle law. It's not any law. If you know till this point, that's it. You don't need triangle law. Kani, I'm just explaining you. Chuskondi. Triangle law is only applicable where the angle between the vectors is not forming. Not forming. It is only applicable when angle between vectors is not forming. So Sarji, you don't need this to be technically correct, but it is there in your syllabus, so I'm explaining you. Okay, what does it say? It is the vector 1. This is the vector 2, sir. Okay, ardhamaindi, understood. So the resultant will have the direction. You see the loop now. Complete the loop. Start from here, you go here. Something like this, kada? Arrow, chuskondi, arrow ni chuskondi. Started from here and went here. So the two sides are completed. Close your eyes and complete the third side of a triangle. Sarji, close your eyes and complete the third side of a triangle. So I have completed the third side. Now, sir, take the opposite direction. Opposite. Arre, what is the direction? Here. It should be the direction, kada? Here. Something like this. Kani, I will not take this direction. I will take the reverse. Reverse. So here, instead of going up, you come down. Ante. This is the direction of the resultant of two vectors. I'm telling you, if you understood the previous discussion, you don't need this law. But still, we have discussed. So, Sarji, can I say this also? So, let's do one thing. Let's try to verify this using our method. Okay, our method. So, what is our method, Sarji? This was my first vector. Sarji, this was my second vector, kada? Okay, sir, the angle between the vectors is not forming, kada? Not forming. So, what to do now? Simply lift it or okay. So, simply lift it and shift it. Shifted, kada? Now, this is the first vector. This is the second vector. Addition is also a vector and the direction of that vector will always be in between the two vectors, kada? So, the direction of the vector will be in between these two. This, choose kondi, same direction, kada? Ante. It is also here, it is also here. If you know this, you don't need this. Or if you don't know this, you need this, but it is, time pass. It's all up to you. Good. Next, if the resultant of two vectors having the same magnitude is equals to one of them, then the angle between the vectors is dash. It has been asked. And I don't know. Leave it. Cheppandi. If the resultant of two vectors having the same magnitude and the same value, kada? So let's say the first value V1 is also V and V2 is also V. Same magnitude, sir. V, same magnitude. Now, the resultant of two vectors is equal to one of them. So resultant is also V, sir. Ante. So these are the conditions. Now I have to find the value of theta. Theta is equals to what? Formula raskondi andariki cheppandi. Formula is V resultant is equals to root of V1 squared plus V2 squared plus 2V1 V2 cos theta, kada? Good. So substitute, Sarji. VR is V, V1 is also V, V2 is also V plus 2 into V1 is also V, V2 is also V into cos theta. Okay, sir. So V is equals to root of V square plus V square ante 2V square plus 2 into V into V, V into V again 2V square, sir G. So 2V square plus 2V square into cos theta. Square cheskondi both sides. Squaring both sides, square chesi, V square is equals to 2V square plus 2V square into cos theta, kada? Good. So, sir, what can I do now is I can take V square common from both the terms. V square common. So, our left side is V square, right side I have taken V square common. What is left? And sir, this is 2 plus 2 plus 2 cos theta kada, v square common అయింది చూసుకోండి, 2 plus 2 cos theta అంతే సర్జీ. Now I will cancel this or divide this v square that side, right? V square by v square అంటే 1. So 1 is equals to 2 plus 2 into cos theta. So sir, this 2 is having plus sign, you send it there, it becomes minus. So 1 minus 2 is equals to 2 into cos theta kada. 1 minus 2 is minus 1 is equals to 2 into cos theta. Ekkad nunchi cos theta is equals to minus 1 by 2. But sir, we know cos 120 is minus 1 by 2 kada. Good. So here, but cos 120 is minus 1 by 2. So here you can simply say theta is equals to 120 degrees. Okay sir, now negative of a vector గురించి చూద్దాం. Not A రే, not A sir ji, ఎలా చెప్తున్నారు sir? How can you say A? Raju sir, how 90 degrees? Not 90. It's 120 kada. Good. Okay, negative of a vector sir. So sir ji, negative ante only the direction is reversed. Ante negative ante only reversing the direction. Ade. So if A bar is equals to 10, it is the value and the direction is on the right side. Chuskondi, andariki chuskondi. If A bar is 10, sir, what about minus A bar sir ji? Minus A bar is minus 10 kada. Are wrong. It's not minus 10, it is 10 only. So minus A bar is also 10, but the direction is in the left side. Ante. Negative of a vector ante only the direction is changing, not the value, not the value. You remember these values, okay? Negative of vector ante only the direction gets reversed. The value remains same. It is 10, it will be 10. But it is right, it will be left. అర్థమైంది అందరికీ? Good. Good. ఎప్పుడు why did I tell you this ray? Because we have to discuss about the subtraction of vectors now. చూసుకోండి. Okay, so subtraction of vectors sir. So subtraction ante A bar minus B bar kada. Good. So sir, A bar minus B bar ela solve cheyalante, you see the directions of A bar and B bar. So for example, this is my A bar and let's say the value is 10. అర్థమైంది అందరికీ? Value of A bar is 10. కానీ the value of B bar, అరే B bar చూసుకోండి రా, B bar is also 10, but the direction is here and this angle is 60 degrees. Sir, I know A bar plus B bar formula sir. What is A bar plus B bar formula sir ji? A bar plus B bar ki magnitude kada. It is simply equals to root of A squared plus B squared plus 2AB into cos theta. I know for addition sir, we just seen for the addition of the vectors. Kani I don't know about the subtraction. So aim cheyalante, you rewrite this expression. I'm telling you, there is nothing known as vector subtraction. You remember this expression, what I'm telling. Vector subtraction, it is not there. We are just doing some smart arrangements ra. We are just doing some smart arrangements. So aim arrangements chestunnaru ante, you write this A bar minus B bar like this. So sir, A bar minus B bar ante A bar plus minus B bar kada. Agree everyone? Agreeing or not agreeing? Andariki cheppandi. Good. Good, good. Very good. Very good. Darkan, very good. Very good, very good. Raju, very good. Very good. Very good. Very good. So it is only equals to A bar plus minus B bar. So sir, minus B bar ante negative of B bar kada. Negative vector ante what sir? Only the direction is opposite. Ante. So A bar is A bar only and B bar is upward direction. Minus B bar is in the downward. Reverse re, reverse re, reverse re, reverse it. So this is my negative B bar vector and this angle automatically comes out to be 120 degrees. అర్థమైంది? Not 120. You can say 180 minus theta kada. So if you want, you can calculate it. Mod of A bar minus B bar is equals to root of cheppandi. If this is theta, if this is theta, how much is it? 180 minus theta kada. 180 minus theta. Cheppandi. So it is A square plus b square plus 2ab cos of 180 minus theta. In basic mathematics, I told you the value of cos 180 minus theta is minus cos theta. Ante. So it comes out to be root of a square plus b square minus 2ab cos theta. Ade. So for addition, plus 2ab, for subtraction, minus 2ab cos theta. You remember this much. Good. Good, Harita. Very good, very good, very good. Next. Cheppandi. It has been asked in NEET 2006 kada? Okay, Sirji. So mod of a plus b. Mod of a plus b. What is mod of a plus b, Sirji? Root of Cheppandi a square plus b square plus 2ab into cos theta. It is equals to mod of a minus b. A minus b ki cheppora. It is a square plus b square minus 2ab into cos theta kada. Square both sides. Square both sides. So root cancel kada. So I left with root cancel root cancel re. How to cancel the roots re? In this time I could also have written the whole formula re. Okay, the square cancelled kada. Squaring on both sides. Square cancelled. A square cancelled. B squared cancelled. Choose kondi here. What can I say re? Minus 2ab, it becomes plus 2ab kada. So 2ab cos theta plus 2ab cos theta is equals to 0. So that means 4ab cos theta is equals to 0 kada. So that means cos theta is 0 re. Cos theta is 0 re. That means theta is how much re? 90 degree re. Pi by 2. Ante. Not A, Spandana. It's not A. It's 90 degrees. 90 degrees, not 45, 90. Don't do these mistakes, Sarji. You just see, you write the equations. Do carefully, very calm mind. Don't hassle too much. Not A. It is D. D. Very good, Raju. D. It's D. Chalo, sir, we are done with the resultant of vectors, kada. So, Sarji, let me just quickly revise. This is B vector, kada. Good. So I can simply say, sir, even if na daggara two vectors are there, something like this. So perpendicular vectors unnai kada. So let's say, sir, this vector is A, this vector is B. The resultant will be between them. Choose the angle between the vectors is valid. So these are the original vectors. So if these are the original vectors, the resultant will be somewhere in between them. Ardhamaindi kada? So the resultant is somewhere in between them. So what we did is, you observe. What we did is, original two vectors were given, we calculated the third. What happens, Spandana? Is it buffering? Okay, you do it. You check it, okay? You try to do it by yourself. Okay. So now, what we did is, these were the two original vectors, kada? These were the two original vectors. What we did is, we calculated the third vector. Two vectors were there, we calculated. Visible, everyone? Is it visible? Visible? Still buffering. Visible kada? Re. Visible? Andariki cheppandi. Yes. Yes. Good. So let's continue. Let's continue. Chuskondi. So what did I do till now is I had these two vectors. I joined them, I form a new vector. Ardhamaindi? I had these two vectors. I joined them, I form a new vector. Now. I will have the original vector. I will break it into two. Hey, what did I say? Till now, there are two vectors where there I joined them, I made the third one. Eppudu I will do the reverse. నా దగ్గర ఒక వెక్టర్ ఉంటే I will break it into the two parts. అర్థమైంది అందరికీ? అదే. So this breaking process is known as resolution. What I'm telling, this breaking process is known as the resolution. అంతే కదా? So now resolution of vectors గురించి చెప్తాం. Any vector can be resolved into perpendicular subvectors, also called as the component of vectors. What did we do till now, Ray? Na daggara there were the two vectors, first one, second. I calculated the net vector kada. I calculated the resultant, and resultant was always between the two vectors. Eppudu sir, I will take the original vector and I will break them into two. Ardhamaindi? Sure. So now I will have the original vector. So this is my original vector and I am going to break them into two. So this is my first subvector. This is my second subvector. Chuskondi. These were my original vectors. I added them. This is formed. Now from this same vector, I am coming back to two different vectors. Ardhamaindi? It is only the reverse. Reverse process. Ante kada? Good. So chuskondi. This was my original vector. I am breaking into two kada. Original vector breaking. Now students, whenever such situation is given to you, they will give you the angle. Which angle, sir? There are two angles, sir. This is the first one. This is the second one. So aim angle గురించి మాట్లాడుతున్నాం. That will be given in your question itself. Chuskondi. I'm telling you the shortcut now. Okay, we are not going into the much technical detailities. Chuskondi. If this angle is given, theta. Chuskondi what I'm telling. If that angle is given, you divide the two vectors into two parts. If this angle is given, you divide them into two parts. This will become the adjacent. Endukante sir, it is exactly adjacent to this angle kada. It is not the adjacent one. Chuskondi. This component is not the adjacent one. This is the adjacent one. Similarly, Sirji, what will happen if this is not given to me and if this angle is given to me? If this is given, cheppandira, then this becomes adjacent kada. Ante. So if this is given, this becomes adjacent. Or leda, if this is given, theta, then this becomes your adjacent. Ardhamaindi andariki, which one to take as adjacent, which one to take as not adjacent. You only take the adjacent vectors. Ante. So this is adjacent. Endukante sir, this angle is given to me. But if it is not given, if this is given, then this will become adjacent. Ardhamaindi? Cheppandi andariki. Tell me re. All of you tell me ra, re, don't do re. Good, Raju, very good. Good. Now, for adjacent, there will always be cos. And the remaining one, see, this is the adjacent and this is the remaining one kada. Ekkada it is adjacent, this is the remaining one. For adjacent, it is always cos ray. For adjacent, it is always cos ray. For adjacent, it is always cos ray. So here also cos. And for the remaining, it is automatically sin ray. I'm not writing. I'm not writing. For adjacent it is always cos ray. For adjacent it is cos, but for remaining it is always sine. You take it by yourself. So Sarji, if at all now I am given with a vector, I must be in this condition to identify which is adjacent and which is not adjacent. Ardhamaindi? Good. Chuskondi. So let's say, sir, this is my original vector. Cheppandi, where will be the resolutions? How will the resolution become? I have to break it into two. So these are the two. This is the first one. I am writing in white, okay? So this is the first one. This is the second one. Similarly, sir, what will happen if my net vector is in this direction? Arre, don't worry, Ra. It is your vector. Break it into two. So this will be your first component and this will be second component. Okay, sir. What if my vector is given in this direction? No problem, Sarji. Break it. Cheppandi, something like this, kada? So the first component will be downwards. The second component will be towards the left. Okay, sir. What if my vector is given something like this? Cheppandi. The first vector ante component, component. I am breaking it. So the first vector breaking is this. The second component is this. Now angle must be given. You don't have to take it. Okay, I will give. The questioner will give. What angle to give, re? Which angle to give, re? Or which angle, re? I am telling this. Theta. Ekkada. Let's say this. Theta. Ekkada. Let's say this is theta. And in the last scenario, let's say this is theta. Cheppandi. Which is adjacent? Which is adjacent? Adjacent, re? Adjacent. Cheppandi. Adjacent gurinchi cheppandi. Adjacent is this kada. Ante. You just write adjacent and finish. Come here. Tell me. What is adjacent, re? This is adjacent kada. Good. You write it and leave it. Come here. Tell me which is adjacent, ra? This is adjacent kada. Good. You write it and leave it. Come here. Tell me which is adjacent, ra? This is adjacent kada. Good. Now this is adjacent. This adjacent, adjacent, adjacent. The remaining one automatically comes to be remaining one. Okay, good. For adjacent, always remember cos. Adjacent, cos. Remaining, sine. Adjacent, cos. Remaining, sine. Cheppandi. Adjacent ante cos. Right? Kada? I am wiping this name. Let it be. Okay, cheppandi. Here also adjacent ante cos. Here also adjacent ante cos. Here also it is adjacent, so it will be cos. Khan, it is not over, it is not over. We have to write it, kada. We have to write it. Cos of what, sir? Are angle re, cos of theta itself, cos theta. Ekkada kuda angle cos theta. Ekkada cheppandi cos theta kada. And here also you will have to write cos theta. Ante. It is still not over. Still not over. Still not over. Good. Let us say this value is A, original vector A. Ekkada vachei original vector B. A scenario lo C and E scenario lo, let's say original vector is D. You multiply it, same vector here, A cos theta. Here also B cos theta. Here also it is C kada, so C cos theta. Here also it is D kada, so D cos theta. Ante. So if you have written adjacent successfully, congratulations, clap yourself. Here also we have successfully written adjacent kada, A cos theta. Here also successfully written adjacent. Here also successfully written adjacent. If one is A cos theta, remaining is sine. I told you kada, remaining is sine. So remaining automatically comes out to be opposite. So it is A sin theta. Ante. This also, Sarji, it is A B C cos theta is there kada. So it will automatically be C sin theta. Ade. Come here. Tell me. It is D sin theta kada. Good. And here, tell me. Cheppandi, it is B sin theta. Ante. So once you have written adjacent successfully, hey, medico, study re, medico, you focus here re, no one is free, medico. Chalo, next. Cheppandi. So if this is my original vector, let's say 100 kada, and I'm giving you this angle, Ray. I told you one angle must be given. One angle must be given. So I'm giving you this angle. The first thing that you will do is to find the components. Cheppandi. This is my original vector. Break it. The two components will be this, and the second will be this. Kada? Adjacent which one, right? Cheppandi. AM component and adjacent, ra? Cheppandi. Tell me, which is adjacent, Ray? Adjacent is this, kada? So it will become automatically cos. What is theta, Ray? Cos 60. And what is the value, Ray? 100. Multiply, Ray. It becomes 100 cos 60. Ante. If it is 100 cos 60, it becomes 100 sin 60, kada? Finish, sir. Gone, sir. Now you have to know the cos 60 value. So 100 into 1 by 2 ante 50. Ekkada kuda 100 into root 3 by 2 ante 50 root 3 kada? Ante. So 1 is 50, 1 is 50 root 3. Very good, Isha. Very good, very good. 100 cos 60 and 100 sin 60. Good. So you have to substitute and you have to break it. So Sarji, what do you think if I have two vectors? The first vector is 50, the second vector is 50 root 3. Sir, do the addition and tell me the net value, sir. I have to add the two vectors. So I have to find the resultant. Cheppandi. What is the formula? V resultant is equal. So what is the angle between the two? 90 degrees. Always remember. Always remember the resultant will be broken into two components. The angle between the two components is always 90 degrees. This angle is always 90 degrees. Kada? Good. Here also the angle is 90 degrees. Now we'll do the reverse. Cheppandi. Root of V1 squared plus V2 squared plus 2V1 V2 cos theta. Theta value enti ra? Theta is 90 degree kada? Cos 90 is 0. It gets 0. Cheppandi. Root of V1 squared ante 50 squared plus root of V2 squared ante 50 root 3 whole square kada? Cheppandi. 50 square is 2500 plus 50 square is again 2500 into root 3 square is 3. So you add it, you directly get 10,000. Take the square root, you get 100. Adi. So we came 50, 50 root 3 get 100. Here 100 is getting into 50 and 50 root 3. Both are the reverse of each other. Arey, why are you spamming, Ray? Arey, everyone has eaten, Ray. Who is this, Ray? Sridevi, everyone has eaten. Chalo, done kada? Arey, let me drink some water. Good. Next. So far so good, students. We have discussed about the resultant. Ante two vectors are given. Add them. Third vector will be formed. The second one, original vector is given. Break them. The two vectors will be formed. Ante kada? Nice. Good. Arey, good, Ray. Good. Okay. Resolve the following vectors. First one. 45 degrees. 10 root 2. This will be your homework, kada? Second one, this is the original vector. Let's say this angle is 60 degrees. Let's say this value is 200. Third scenario lo, let's say this angle is 30 degrees. Array 100 ray. Next. Fourth scenario. This 60, 100. Fifth. 45. 120 root 2. In sixth. Homework. 60, 60. చెప్పండి అందరికి. It's 7:32 రే. Let's see. Done. Okay, Sarji. So till this point, what I've discussed is, I discussed na దగ్గర ఒక force ఉంటే I can resolve into two different components కదా. The first component will be in this direction. The second component will be in that direction. So sir, it is x-axis and y-axis kada. Good. Array, all the questions that we see, the forces were either something like this or something like this or something like this. Array, how should I? Or something like this. Something, or something like this. Kada? So these were the four scenarios. Array, all the vectors were along x-axis only. But, vector resolution need not be always along x and y-axis. For example, Sarji, let's say, na దగ్గర ఒక slide, this is a slide kada, wedge. ఇది angle ante, let's say this is theta angle. Let's say this is mass m ray. Let's say this is mass m. mg direction cheppandi. mg is acting vertically downward kada. Good. Array, why we resolve the forces, ray? Why do we resolve the forces? Because it is not compulsory that where you apply the force, the motion should also happen in that direction. mg is acting in the downward, but the block is moving in the cross direction. So in this case, we don't see mg. We break down mg forces. So sir, I can see the motion is in the downward direction kada, cross. So that means mg component is there in the cross. If it is gravity free space, it will not fall na. It is gravity free space, it will not fall, right? So it is falling only due to gravity kada. So there is this force, and if this is one force, చూసుకోండి, if this is one force, what you do is you simply reverse it. Array, what should I do, Ray? Array, it's not possible to rotate, ra. Let's try to do it. Okay. Array, how to do it, Ray? No, we do have the solution for this. Anyways, chusko. This is the first vector. If I see in this direction, the second component will be perpendicular to it kada. Chudandi. This is my original force. This is my first vector. No. Okay, so this is my original force. This is my first vector. The second one is perpendicular to it kada. Perpendicular. Ekkada kuda the first vector is here. The second will be perpendicular. This is the perpendicular direction. This is the perpendicular direction. So mg force is getting into two components like this. It is only because of your axis ray. You just reverse it. This is my x-axis, this is my y-axis, and this is my force. Ante kada. So sir, if this angle is theta, this is also theta kada. Okay, that means this is adjacent ray. This is adjacent ray. So if this is adjacent, it will be cos ray. Original force is mg, multiply with cos theta. Ante. And this will become mg sin theta. Ante kada. Good. So remember, if at all an object is kept on a wedge, mg sin theta will be downwards. Ante. Finished. Okay. Next thing will be done with the half. Types of vector, zero vector ante enti ra, magnitude 0 ante. The magnitude of the vector should be 0, it will call zero vector. Magnitude is equals to 0. Equal vectors enti ra, the vectors should have same magnitude and same direction also. Same magnitude, same direction. Equal vectors ante same magnitude and same direction. Ante. So then you can say The two vectors are equal. So this is A bar, this is B bar. Same length kada? Same length. Same length. Okay, so this is A bar and this is B bar. And direction also same. So A bar is equals to B bar, you can say. Parallel vector ante, the two vectors should be in the same direction. Ante. You can say they are less or they are more, but direction is the same. Unit vector is important. Unit vector is important. Unit vector is important. Okay? Okay. So unit vector ante value or magnitude should be 1. Okay. So why do we use unit vector? Unit vector we only use it to convert a scalar into vector. I'll tell you later. Chuskondi. Position vector ante x-axis, y-axis undale, and you can simply say position vector ante the vector joining the origin to the point. Let's say this is point P re. This is point P re. Join the origin re. Join the origin re. Origin join cheskondira. This is the position vector of point P. Ante. Okay? Done re. Done. Done re. Done. Arey, what are you talking re? Pawan Manikanta, where did you see me in Hyderabad re? Cheppo, where did you see me in Hyderabad? Okay, significance of unit vector. Aim significance ra. Sirji, we use unit vector to convert a scalar into a vector quantity. Okay. So if I say I am applying a force of 10 Newton. Arey, information complete or incomplete? Cheppo. Arey, 10 Newton is complete or incomplete? It is incomplete. Incomplete. So what I do, I say, sir, let's say this is a vector, its value is 1 unit. What do I say? This is a vector, its value is 1 unit. Arey, simply pick and multiply. Ante. What do you do? Vector, direction. Chuskondi. Direction. Magnitude is 1. You lift it, you multiply it. Ante. Now, this pen is giving the direction of this 10 Newton. Ante kada? Again, I'm telling you. The unit vector is always used to convert a scalar into a vector quantity. Scalar ante it has no direction. Vector ante it has a direction. So, ela convert cheyalante, you take a unit vector and you multiply. So, unit vector has a special remembrance. We say A bar for a vector. If A bar is a unit vector, you can also write the same A bar as A cap. A cap. Ardhamaindi? So, Sarji, if A bar is or A cap is in this direction, I don't know the name of this direction, kada. It is x-axis, this is y-axis, or this is z-axis. But what about this, sir? What axis is this? I don't know. So, let's say it is n cap, n-axis. N-axis ra. So, I'm simply saying n-axis is there, and it has a unit vector only, kada. So, n cap. So, n cap ochi, you can understand that it is a direction. It is talking about a direction. Ardhamaindi kada? Good, very good, Raju. So you can simply say A cap is equals to original vector A bar by magnitude of A bar. Ante. Only the direction, magnitude, you divide it, this magnitude and A gets cancelled, only bar is left. So bar is for representation. Ardhamaindi andariki? Good. Next. Oh, Sarji. We are coming to the fancy topic of the discussion. So now we will be interested only in talking about the multiplication of vectors. So, sir, we do have two types of multiplication. One is a scalar product and the second is the vector product. So, how will you differentiate it? Chuskondira, scalar and vector multiplication. Ante kada? Only two types of multiplication. So, sir, in numbers, we can multiply simply kada. We can simply say 3 into 4 is equals to 12 ray. We can simply say 3 into 4 is equals to 12 ray. but vectors లో మల్టిప్లికేషన్ చేయాలంటే there are two different types I can do it. అర్థమైంది అందరికీ? వెక్టర్స్ మల్టిప్లికేషన్ అంటే we have two different methods. What is the first method, Ray? What is the first method to do the multiplication ante? It is a scalar multiplication, dot product. As the name suggests, dot product ante ఒక scalar quantity. అంటే multiplication చేసి వచ్చిన ఆన్సర్ అంటే it is a scalar quantity. And cross product or vector product ante it's a vector quantity. అర్థమైంది అందరికీ? So scalar and vector are a difference రే బాబు, అర్థం చేసుకోరు. రే చూసుకో. So the first one is the scalar multiplication. So Sarji, eppudu scalar multiplication gurinchi maatladtam. Raju, you did not understand. Raju, what is the problem, Raju? Arey, you are a topper, Ray. I can understand, Raju. You must understand it, okay? So first one is the dot product. Very simple steps, very simple procedure. What are the steps and what is the procedure, Sarji? నా దగ్గర two vectors ఉంటే, let's say this is the first vector, and let's say I should take it something like this, okay? So that the shift, okay, these are the two vectors. అర్థమైంది అందరికీ? Oh, bro. Hey, bro, you observe on this, bro. Don't spam, bro. Okay, chusko. If at all I'm saying this angle is theta, let's say the value of the vector is A. Let's say the value of the vector is B. అర్థమైంది కదా? So now, when you are going to take the dot product of the vectors, dot product of the vectors ante sir A bar and dot product ante simply take a dot ante. This is the dot product. What is the formula, Sarji? What is the formula, Sarji? What is the formula ante? The formula is simply A into B into cos theta. What is cos theta? Cos theta ante theta is the angle between the vectors A bar and B bar kada. Good. So now, Sarji, is it angle between the vectors? A scenario lo, is theta the angle between the vectors? Yes or no? No. So what to do, sir? Convert it. Ela convert cheyalante? Shift it. Cheppo. So now you can simply shift this vector and you can say, Sarji, I'm shifting it this way. And once I shifted it, sir, this vector becomes something like this. And this angle will automatically be 180 minus theta kada. So in situation low, what you do is shift 180 minus theta is there. AB cos theta ante A into B into cos of 180 minus theta kada. Right. Good. What is cos 180 minus theta, sir? Minus cos theta. Good. So it is simply equals to negative of AB into cos theta. So A bar dot B bar is AB cos theta. It's a simple number. That is why it is said as scalar product or scalar multiplication. Simply number, ante, nothing, only the number. Chuskondi. So let's say this vector is 10. Let's say this vector is 20. And the angle between them, theta is equals to 60 degrees. In situation low, if I have to talk about the dot product of the vectors, so you can simply say A bar dot B bar is equals to AB cos theta kada. A is 10, B is how much, right? B is 20, cos theta ante how much, right? Cos 60 kada. Good. So it is 200 into cos 60 is half. 200 into half is 100 only. So this becomes my A bar dot B bar. And there only the number, nothing other than that. Watch it. Yeah, nice language. Next. So let's discuss about three different cases: parallel vectors, anti-parallel vectors, perpendicular orthogonal vectors. So if the two vectors are parallel, ante the first vector should be like this, the second vector should be like this. Now students, let's say this is 10, this is 20. What is the angle between the vectors? Observe cheskondi. I'm asking you again and again. Chuskondi. If this is 90 degree, ante kada? Situation something. Am I visible? Yeah. Sir, if this is 90 degrees, I'm reducing the angle. Chuskondi. I'm reducing 90, 45. 45 nunchi I'm bilkul making it straight. How much? 0. 0 kada? Angle between two parallel vector is always 0. Ante. So here the value of theta is equals to 0, sir ji. Other you substitute. So you can say, sir, a bar dot b bar is equals to a into b into cos theta kada. A ki value ante 10 into b value ante 20 into cos theta ante cos 0. So cos 0 how much, sir ji? Cos 0 is 1. Cos 0 ra. So it should be 10 into 20 into 1, that means 200. It is the value of a bar dot b bar. Ante kada? Good. What about anti-parallel vectors? Anti-parallel vectors ante opposite directions. So first vector will be towards the right and the second vector will be towards the left. Ante kada? I'm giving you the values also. 10, 20. How much angle? Are they the same thing if it is if it is 90 degree, it is coming 0, 0, 0. Now 90 degree increase 100, 110, 120 and this becomes 180. 180 ra. 180. 180s. Good. So the theta is 180 degrees. What to do? Theta is 180. So from here, a bar dot b bar is equals to ab into cos theta kada. Chappura. A ki value 10, b is 20, cos 180. Now students, andariki you must remember the values of trigonometric numbers. Cos 60, cos 45, cos 90, cos 180. How much? You remember it. Cos 180 is minus 1. So it is minus 200. Ante kada. A bar dot b bar is over. Now let's talk about perpendicular vectors. So perpendicular vectors ante what happens? What happens in perpendicular vectors? The first vector is upwards, the second vector is in the left side. Angle is 90 degree. 90 ante perpendicular kada. So you can simply say it is 10, it is 20, angle is 90. So a bar dot b bar is equals to AB into cos theta. Theta is 90. Theta 90 unte cos 90 is 0 kada. Good. Chalo. So now, can I simply say that cos theta is cos 90 and cos 90 is 0, So if cos 90 is 0, so what you can say now is, it is equals to A is 10, B is 20, cos 90 is 0. So the total answer comes out to be 0 itself. So if the total answer is 0 only, you remember that these are the perpendicular vectors. Ante. Anyone, any doubts, any problems? Tell me. Good. Very good. Neeraj, very good. Neerja. Next. Find the dot product of the following. Do I need to give you the questions? Or you understand? I'll skip it, okay? I'll not waste the time in it. I'll skip it. Okay, dot product as a projection of a vector. Ardham cheskondi andariki. If I have a triangle, right angle triangle more specifically, if I have a right angled triangle more specifically, let's say this angle is theta. Let's say this side is A. Let's say this is X and this is Y. Observe cheskondi. Horizontal side is X, vertical side is Y kada. So now tell me the cos theta value. What is cos theta? In any triangle, cos theta is adjacent side by hypotenuse. Similarly, you can say sin theta is opposite side. Opposite side enti ra? Y kada. So the opposite side is y by hypotenuse is a. So ekkada nunchi what you can say about x is equals to a into cos theta. And what you can say about y is equals to a into sin theta kada. Good. Now students, I want you to remember this. Sarji, if at all I have a triangle, let's say the horizontal side or the adjacent side of the angle theta. So if this is A, this automatically is the adjacent side kada. We also did it in the resolution of the vectors. What did we say, Re? We said that if this side is A, it automatically comes out to be A cos theta kada. So A cos theta is the projection of this side, I can say that. You remember, Ray, I'm telling you, that's why you remember. Why, sir? Why projection? Ante, you do one thing, you take a big torch. Big torch, you hit it on this side A. What will happen, Ray? Shadow will form. What will be the length of the shadow, Ray? Same, A cos theta, ante. That will be the length of the shadow. So that is why we say it to be the projection. Ardhamaindi andariki. So this is projection of A. Why, sir? Because you take a bigger torch and you shine it on side A, it will leave a shadow and the length of that shadow will be equals to A cos theta only. Ardhamaindi? Are ardhamaindi? Chappora. Chalo, good. Very good. Next, so I'll add one more slide and let's talk about the dot products now. So, Sarji, let's say this is my first vector A bar. Observe it very carefully, very carefully. Let's say this is my second vector B bar kada, and let's say the angle between them is theta. So, sir, what did I say? I said that you take a torch. So, this is the torch. You hit the torch. Where will the shadow fall, right? The shadow will fall simply on this side kada. So, this is the shadow. So, sir, the line will be something like this kada. So, this is the shadow. Kada? The shadow or the projection of B bar. Can I say that? So that is the projection of B bar ray. Now, sir, what can I say to this length, Sarji? This length is simply equals to, Chappandi, can I simply say this length is B into cos theta? Ardhamaindi. But what was the original vector, sir? Original vector was A bar. And this length is B cos theta. So, sir, I only have to find this B cos theta. I'm not interested about dot product. I only have to find B cos theta. Projection. So, sir, do one thing, do the cross product. So, A bar dot B bar ante A into B into cos theta kada. Good. So, B cos theta is the projection. Choose kondi andariki. B cos theta ante what is it? It is the projection of B bar on A bar. So A is multiplication, send here in division. So A bar dot B bar divided by A is the projection of B bar on A bar. Similarly, A bar dot B is projection of A bar on B kada. Ante. A bar on B bar. Ade. So that was something I was interested in. Let's go towards one more next step. Time is there. Okay. Arey, yeah, really are Maitri. They have been, completely spamming the chat. Brother. Chalo. Let's talk about the cross product rate. What is the cross product rate? Cross product ante, what we do is we take the cross product of the two vectors, as the name suggests, vector multiplication kada. So multiplication chesi ochina answer, that will also be a vector. That is why vector multiplication is there, right? So vector multiplication ante, take the cross product and that will also have a direction. Value is already there. In addition to value, there will also be a direction. Ante. So that is the reason why we call it as cross product of the vectors. Ardhamaindi andariki? Good. So now, Sarji, how to do the cross product? Remember, always take your right hand. Always take your right hand. Which hand is it visible? Is it my left or right in your frame? It must be my left hand kada. Because the camera is there, or whatever it may be. Take your right hand, okay? Always take your right hand. Do one thing. If at all you are given two vectors, this is vector A bar and this is vector B bar. Let's say the angle is theta. You must verify if the theta is the angle between the vectors or not. If it is not there, shift, convert, do it. So if A bar cross B bar is to be found out, what you do is take your right hand, your four fingers should be in the direction of A bar and your palm should be facing B bar. Your four fingers in the direction of A bar and your palm is facing towards the B bar. Cross product. Where is the thumb pointing? Towards you. Kada? Where is the thumb pointing? Towards you. So that would become the direction of cross product of the vectors. Again I am telling you, take your right hand. That's it. See, this is the figure. Take your right hand in the direction of A bar. Visible? Not visible? Not visible. Yeah, now it's visible. Kada? Okay, take your right hand in the direction of A bar and curl your fingers in direction of B bar. Kada? Your thumb is giving you the direction of A bar cross B bar. Again, I'm telling you students, take your four fingers in the direction of A bar, point them or curl them in the direction of B bar. The thumb is giving you the direction of A bar cross B bar. Outwards. Very good. Very good. Harita, very good. Now we are confused, kada, what to say this direction, and sometimes if the direction is inside the plane of the paper, how to name it. So you remember, dot, circle, and it is coming out, outwards. Outwards, something like this. And if it is a cross circle, that means it is going inside. Focus. Chalo. So cross product is, I've told you to find the direction now. What about the value, Sirji? Value is simply A into B into sin theta. For dot product it was cos theta. For cross product it is value AB sin theta. But the direction is there, kada? This direction. So only to show the direction, what did I say? We multiply it with a unit vector, kada? Unit vector. Why we multiply? To convert a scalar into vector. It is a scalar, but I don't want a scalar. I want a direction also. So n cap is extra added. So you can simply say A bar cross B bar is equals to this. Ardhamaindi andariki. Okay. So this X, or you can say simply this cross, right? So this cross followed by a circle, and it is inside direction. And Sirji, when it is a dot and the circle is there, that means it is coming out of the plane of the paper. Who was there, Re? Who was telling that he saw me in Hyderabad, Re? Who was there in the comment section? Chalo, next. So now, if I'm only asking you about the directions, Re, cheppandi, what are the directions? So A bar is here and B bar is here. Students, before that, observe if the angle is forming or not forming. If the angle is not forming, your direction will be gone. It will not be right, okay? It will 100% be wrong. So angle, is the angle forming here, right? Theta? Yes, sir, it is forming. So let's say it is the direction of B bar. Cheppandi, where is the direction of A bar cross B bar? Where is the direction of A bar cross B bar? Andariki. A bar in the downward direction. You curl your fingers towards B bar, kada? Something like this. From A bar to B bar. Where is your thumb pointing, right? Your thumb is pointing inside, kada? So you can simply say A bar cross B bar is into the plane of the paper, kada? So A bar cross B bar is into the plane of the paper, something like this. Similarly, if I said you to find this is A bar, cheppandi andariki. So A bar cross B bar into the plane of the paper. Again, chuskondi andariki. A bar cross B bar is into the plane of the paper again. Here also A bar cross B bar is into the plane of the paper. One last example, students, and then we'll try to understand about more. So choose kondi. If this is my vector A bar and this is my vector B bar, where do you think A bar cross B bar is? Where do you think A bar cross B bar is? Inwards? Are you sure? Arey, B bar ki value I did not give it. I did not give it to you. So sir ji, A bar cross B bar, A bar is here, B bar is here, cross it, it will coming outwards. Not there, Ray. It's wrong, Ray. It's wrong, Ray. It's wrong. What to do now, sir? Shift, shift, shift. Why? Because angle is not forming, sir ji. It is the head to tail. So you do one thing, sir. You simply pick. Oh my goodness. Okay, so you simply pick it, right? And you simply shift it, right? Something like this. So B bar is also shifted, kada. So B bar is also shifted. Now tell me, A bar cross B bar kada into the plane of the paper. Good. Good. Not out ray, it's in ray, it's inside ray. So far so good. What I have observed is that the majority of the students who are attending this class are typing nonsense in the chat box. No, that does not mean all of them are there. There are some interested students or some sincere students also. Very good, Raju, very good, very good. But most of you, I can say, not most of you, quite a few of you are doing spams. Okay, don't do it, Ra. Don't do it, Ra. Okay. So cross product, sir ji, cross product is a very dangerous thing, sir, because it has both magnitudes and directions. Okay. What is the geometrical interpretation of cross product, Ray? Why we do it, Ray? Why we do it? What is the geometrical interpretation? Observe cheskondi. If at all I have a first vector, now how to show it? I hope there are some pens visible. Yeah. Luckily there are some pens visible. Okay. So sir ji, I have two different vectors. Observe cheskondi. This is the first vector and this is the second vector. Are you visible? Are you observing them? But they are both in the horizontal plane, kada. So these are the two vectors. How can I say? Yeah, this. Something like this. So sir ji, this is A bar and this is B bar. A bar, B bar. Ardhamaindi? So now what can I say is I can do the cross product. Start from A bar, go to B bar. The B bar or the cross product is perpendicular, right? In the upward direction. Andariki, chooskondi. So what can I say about the geometrical interpretation is that this vector B bar, or sorry, this cross product array, adjust it, yeah. So this is my vector A bar, this is my vector B bar, this here is the cross product. You observe the angle, Ray. What is the angle between these two, Ray? 90 degree, kada? What is the angle between these two, Ray? 90 degrees. Similarly, observe these angle, Ray. What is the angle between these two, Ray? 90. So that means if at all you have two vectors, this was my vector A bar, this, no, not like this, Ray. Okay, so this was my vector B bar. Same plane, huh? Same plane, B bar. Do the cross product and the cross product will always be perpendicular to both of them. So this is A bar cross B bar. Angle choose kora. A bar and perpendicular 90 degrees. This is also 90 degrees. Ardhamaindi? So the cross product is perpendicular to both the vectors. Okay, Spandana. I'll give you. Okay. Okay. So I'll send you by post or delivery or blue dart, whatever. Ray, you observe. If at all A bar cross B bar is a vector and it is perpendicular to both A bar and B bar. That means the vector A bar cross B bar, it is perpendicular to A bar also, and the vector A bar cross B bar, it is perpendicular to B bar also. So, Sarji, what could we say about the perpendicular vectors? Their dot product is 0, kada? Good. So, if at all it's a new vector, let's say C bar, for some time being, I'm telling this to be C bar, okay? So, this vector I'm calling it C bar. This vector I'm calling it C bar. C bar perpendicular to A bar, kada? C bar perpendicular to B bar. Perpendicular vectors ante C bar dot A bar should be 0. And similarly, C bar dot B bar should also be 0. So, such a substitute cheskondi. C bar ante A bar cross B bar kada. So, A bar cross B bar dot A bar is 0. Similarly, A bar cross B bar dot B bar, it is also equals to 0. Ante. These are the geometrical interpretations of A bar cross B bar. I want you to understand this. Okay? Done. For now, we can stop here itself, right? Andariki, can we stop? Can we have a end of this session here, right? Cheppo, andariki cheppandi. Good. So I think we can stop here itself. Chalo. Very good night to all of you. Very good night, andariki. Yeah. Yes. Bodhi Dharma. Chalo. Bye. Bye, Maitri. Bye. Take care. Yeah. I think there is a half more chapter left. We have to discuss about the IJK representation of the vectors and also about the dot product and cross product of those vectors also. Harita, that's not in my hands, okay? So, information gurunchi, I will have to ask the seniors, but that would also not be a fruitful conversation anyways. So, not in our hands, Re Baba. Harita, I told you. So, it's not in my hands, Re Baba. I am not the owner of this channel, kada. So, yeah, you can tell the authority. Naku teliyadu. I don't know anything about it. Tanuja, aim questions. What questions you have? You tell me. If you have any questions, we'll take it here itself. I can't block it, Re Baba. I can't block the chats. Good. So can we finish? Thank you so much, Isha. Thank you so much. Good night, Shalini. Good night. Thank you so much, Raju. Thank you so much, Bodhi Dharma. Thank you so much. It means a lot, right? It means a lot. So I'll mostly export it as PDF. Should I name, right? Should I name? One, two. Good night. Andariki, good night. Good night. Bye. Bye. Chalo, done? Thank you so much, Spandana. Thank you so much. Yashu, we don't have that much time, kada. It's not completed. The chapter is not completed. Kani 60% is completed. You know, I can say 60% has been completed, 40% left. So we'll complete it on Monday. Monday for sure. Sunday for electrostatics, right? Tomorrow electrostatics. Chalo, done. So I think we can terminate this session. All of you, good. Chalo, good to go, good to go, good to go. Next session timing would be tomorrow 5 p.m. Tomorrow 5 p.m. 5. Next session tomorrow 5 p.m. It might last for 3 or 4 hours. Okay, so lengthy session. We'll be trying to complete entire electrostatics in that. Okay. Chalo, bye, 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 Andariki, bye. Thank you so much, Harita. Thank you so much, Teja, Shalini, Isha. Thank you so much.